Now that we have an idea of how our database should look like, let's finally create our tables on Supabase. There are two ways to create the tables on Supabase, either using the SQL editor or the table editor. With the SQL editor, you need to be familiar with the SQL language. For simplicity, you can use a table editor, which we will proceed with. In the case where you need to run any SQL query, SQL editor is where we go. Now let's start with the public schema and create our three tables. First, we'll have the profile table. So we'll proceed to click on create a new table, and we'll give the name of our table as profile. The work of this table is to hold information about the logged in user, or the user who is getting into the system. But please note, this tutorial focuses on the Supabase database feature only. Once we interact with the authentication feature, there will be advanced changes, but nothing to worry about for now. So we'll proceed to insert a description here. Then there's this part where that enables row level security. We leave it as is. In the later lessons, we'll discuss what this is in detail. We'll also leave the Realtime disabled. This is another important feature that is provided by Supabase. We'll discuss it in a later tutorial. Now we can define our columns. In a database, there are fundamental elements called keys. Keys are used to identify, link, and ensure the integrity of data within tables. We'll interact with two main keys. There is a primary key. The primary key is a unique identifier for each record in a database table or each row in a database table. Each table can have only one primary key column. Some of the characteristics are each value in the primary key column must be unique. Primary keys cannot contain null values and can be a single column or a combination of columns. Based on our database design, all our tables will have a primary key column. Then we'll have another key called a foreign key. A foreign key is a field in one table that uniquely identifies a row of another table or the same table. This can be one field or a collection of fields. The foreign key is defined in a child table but refers to the primary key or a unique key in a parent table. Some of the characteristics are it establishes and enforces a link between the data in two tables and also ensures referential integrity by making sure that the foreign key value in the child table matches a primary key value in the parent table. We'll be defining a foreign key column for some of the tables but not all. Back to our table. By default, when you create a new table, it comes with two columns. The first column is called the ID, which is set as a primary key. You can change the name of the column to your liking. The second column holds the timestamp of when the record was created. The column name is called created at. We'll retain these two columns. Then let's add other columns. We'll have a column named name. This will hold the name of the logged in user. It will hold a data type of text. Next, we're going to have a column called phone number. And this will hold the phone number of the logged in user. It will hold the data type varchar. Then we'll add another column called email address. And we'll give it the data type of varchar, which also represents the email address of the logged in user. Then we can proceed to click on save, and we're done creating our first table in our public schema. There we have it. Before we proceed to the next table, I just want to show you a sec where if you need to edit the columns of a specific table, all you have to do is click on this these dots, and then you'll click on edit table. And then, for example, I have decided to make sure that the phone number is unique. I just come to the settings icon over here and set it as is unique. And then after doing that, make sure you click on save. So that's how you get to update your table within Supabase. So now that we have that, let's create another table. So to create a new table, we just come here and click on new table, and we'll proceed to create the vehicles table. The work of this table is to hold information about the vehicles registered in the system. So we'll retain everything all the way here, even the two columns, and then proceed to add our new columns. So we first have user ID. This will specify the owner of the specific vehicle. So we'll have the user ID, and then we'll give it a type of int8. Then at the bottom, there's a section where you get to create a relationship or a foreign key relation. So all you have to do is, because we want to create a relationship between the vehicle table and the profile table. So we'll just come and click add foreign, and then we select a table to reference to. So we'll just click on profile because that's what we need. So in the in the vehicle table, we want to create a relationship between the user ID column and the ID column in the profile table. So simply that's what you do, and then you click on save. There are other settings that you can do, for example, delete cascade or update cascade. What that means is you can automatically set that whenever the child record is deleted, the parent record should also be deleted, or if whenever the child record is updated, the parent record is also updated. But we'll just leave it as is right now by setting no action, and click on save. The next column will be the car model, and we'll give it a data type of text. It defines the model of the user's car. Next, we'll have the car number of data type numeric. This you can change it according to how you set your car numbers wherever you are. But for this one, I'll just set it as numeric. Then lastly, we'll have the car color. I'm counter checking with the data schema, and then we'll just set it as text. Let's just make sure when we're adding all this, the user ID is not nullable, and also the car model is not nullable, does not return null. That's what it all means, even for this and for this. So we need values passed in. That's what it means. So let's proceed and click on save. So we have one relationship we've created between the profile table and the vehicle table. I forgot to describe or create a description for this vehicle, so let me just add that. Click on save. Great, so now we have two tables. Since the remaining table in the public schema depends on another table, let me show you. So the remaining table in our public schema is favorite, and it's dependent on a relationship to it. We have a column called parking area ID, which creates it's a foreign key that creates a relationship between the favorite and the parking area. And for us to completely finish this table, we'll need that parking area. So the thing that I'm saying is that we can now proceed to switch our schema from public to parking and create our parking area. Then we'll go back to the public schema and define our favorite table. So now that we're in our parking schema, let's create a new table and call it parking area. We'll give it a description. So it holds a list of parking areas. I'll share a CSV file in the GitHub repository where you can actually upload some of the list of parking areas for your own testing. We'll leave the settings as they are, and it comes with the default columns. So now we can proceed to add new columns. So we'll add a new column called name. give it the data type of text. Then we'll just make sure that it's not nullable. We'll add a new column called parking fee and give it the type numeric. This refers to the fee or the cost of the parking in that specific parking area. Then we'll add another column called location text. Other than the name, you'd want to provide more information about where this parking is. So we'll give it the data type of text. Then before we proceed, let's have a quick look on PostgreSQL extensions. I felt like this specific table will be a nice table to talk about it. So extensions in PostgreSQL are packages that add functionality that isn't part of the Postgres core, what's already in the core. So extensions are whatever is not in the core, that is like maybe we have default data types that are usually in the core, but to access other types of data types, you need to add an extension to the Postgres core. So I'm going to use this parking area. Just create a simple column. We don't need it from based on our schema. We don't need a column. I'm just going to add it, and then we're going to remove it just to showcase on how to add extensions to your table. So what I'm going to do is I'm just going to click on save on this specific table. Let's just click on save as is. So what I want to do is to allow us to create a column that will hold coordinates of a parking area. Okay, so coordinates is where you hold the latitude and the longitude. So to be able to store coordinates in our PostgreSQL database, we'll need a specific extension in Postgres, and there's one that's available that's called Postgres. So to add an extension to your project, all we have to do in Supabase is we head over to our dashboard and go to database. Then we have a list of menus here. We head over to extensions. Then we search for the specific extension that we need, and in our case, we need the Postgres. So we'll just enter Postgres, and here we have it. And all you have to do is just enable it. As simple as that. Just confirming by saying enable extension. So it will enable the extension for us. So when we proceed to go back to our table editor, then we head over to the parking schema. Here's our parking area table. So we'll just click on edit table, and let me show you how to create a column that holds the coordinates. So if we create add column, I'll come here and give it the name like location point. And then if I want to set the correct data type that holds the coordinates, it's the correct data type that holds the coordinates in Postgres is called geography, and we can't access that data type without the extension that we have enabled. Now that we have enabled it, we should be able to see it, and here we have it. So we're going to just click on geography, and there we have it, and we're able to proceed to save our table. So that's how you use PostgreSQL extension. The extension, how to add extensions in the core is as simple as that. So now that we understand that, I'll just remove this column and we can proceed to create the rest of our columns. So now we'll add a column that will hold the rating, and it will have the data type int2. Then we'll have another column called local description. This refers just to the description of the parking area. Description. Yep. And then we'll give it the data type of text. Where's text? There, yeah. And then now let's have a look at arrays. You can also set your columns in arrays. So when working with arrays, it's very simple. Supabase made it very easy for us. All you have to do is set a column with a data type of text. So in our case, we have two columns that we'll need to set as arrays. We have location images that will hold the URLs, a list of image URLs. showcasing the parking area. So we'll just give it the name location images, and then we'll just set it as text. And then we'll head over to our settings and just define it as an array. As simple as that. Now let's proceed to create another column called amenities and do the same thing. It will also hold a list of amenities in that specific parking area. So we'll click on text and define as array. And just simple as that, we are finished with designing our parking area, so we can just proceed and click on save. So back to our public schema, we can now finally design the remaining table, if you remember, called favorite. So let's just create a new table and give it the name favorite, and we'll give our description here. Of a specific user areas, because one user may have multiple favorites. Great. So we'll leave the settings as they are, have our default columns, and now let's proceed to add our two columns. So if I go back to the schema, if you look at the favorites, all it has is the user ID and the parking area ID. And what's unique about these two, these are a collection of foreign keys, because this user ID creates a relationship between the favorite table and the profile table, and this parking area ID creates a relationship between the favorite table and the parking area table. So that we'll be able to do that quite fast. So we'll have the user ID, we'll give it int 8, and then we'll proceed to add another column. Let's just add both of them. Parking area ID, and give it the, let me just name it properly, and give it int 8. Then just proceed to down below and add our foreign key relations. So we're creating first the relation between referencing to the profile, and then we just want to connect the favorite user ID with the column ID in the profile table, and then we just click on save. We also want to create another relation reference to, we're going to reference to the, let me select the right schema, which is a parking schema. In the parking schema, we have the parking area table. So we're going to create a relationship between the parking area ID with the column in the parking area, which is the ID, which is a primary key, and then we click on save. So now we have our two relations here. Now we just click on save and we are done. Back to the parking schema. Now we are done with the public there. So let's create a new table called parking detail. This will contain information, parking information for a particular user. So we'll leave the settings as they are and proceed to add our new columns. So our new column will have parking date, and we'll give it the data type of date. Let's make sure it's not nullable. That's an important information from this table. Then we'll have the entry time. We'll set it with data type of time. Add another column and give it the name duration. This will be in hours. I will have defined it in the front end. So just give it int 2 and make sure it's not nullable. Then let's add another column for exit time. and set it as time. Let's add another column for parking area ID. Int 8. This will allow us to create, this column will create a relationship between the parking detail and the parking area. So the beauty of having this relationship is that I don't need to have the whole information about the parking area that the user has booked. All I need is a parking area ID. And through this ID, I'll get the rest of the information about that parking area. So that's the role that foreign keys do. So that we're creating a relationship so that all I need to do is save the reference, which is the ID of the specific parking area. And then with that reference, I'll be able to head over to the parking area through querying, of course, and get more information about this parking area. Next, we have, what else do we have? Let's add the user ID, which will also allow us to create that relationship. We'll just have data type int 8. So if we want to know which user has booked this, created this specific booking, we don't need to have all the information about the user here. We have a reference to the profile table. Great. So we'll create the relationships down below. Let's just make sure we have all our columns. So we have the parking area ID. We also need the vehicle ID. So int 8, which will be a reference to the vehicle table. And then lastly, I think we'll have the parking slot. But we'll add that later because we don't have the parking slot table yet. We'll add that later, which I think will be the next table. So let me just delete that. Just make sure that it's not nullable. Great. So now we can save this. Before we save, let's add the foreign key. So we have 3 specific columns that we need to create a relation with. So we'll start by, let's see, we'll start with the parking area. So all I need to do is specify the correct schema, which is parking. And then we select the parking area. So we'll pick the parking area ID column and create a relationship with the ID, the primary key of the parking area table. Click on save. Then let's add another one, which will be for the user ID, which is in the public schema, which is in the profile table. So we'll just create a relation between the user ID column and the primary key column of the profile table. Click on save. And lastly, we'll have the vehicle ID, which is in the public schema, and we'll just reference to the vehicle table and create a relationship between the vehicle ID column and the primary key column of the vehicle table. Click on save. So we have another one that we'll add over here, but let's first create its table. But that's all we need to do on the parking detail table. Let's click on save. Before we proceed to creating the next table, I just wanted to talk a little bit about managing enums. So Postgres also supports data type enum, which you'll have to create it on your own and define it as a custom data type. So let's say, for example, in our backpacking detail, if we wanted a column that holds status, for example, if the packing is ongoing, completed, or cancelled. So if I wanted to hold such a status, enum will be a perfect data type to have instead of having to define the text itself, like the actual text ongoing, completed, cancelled. I can have an enum variable that will hold them, and then all I have to do is just reference from the data type or the data type itself. Let me show you what I mean. So let's proceed to the SQL editor. I can just continue from here, or let me just create a new query. So let's say I want parking status, three parking statuses: ongoing, completed, and cancelled. But I want to set them as a num. So what I need to do is I need to create a custom data type myself. So I'll just use the create command and then define a type and give the name of my data type, my custom data type. And in our case, we can just define it as parking status and then define it of which as a num. That's how you do it. And then now you define all your variables. So we have ongoing, we have completed, and then we have cancelled. So those are the three statuses that we want to hold. Okay, so now we can run this code, this query. So it's successful. So we now have this type, custom data type, in our premise. So what I want to do now is in the parking detail table that we have, I want to alter it a little bit and add a new column called status that will hold a data type of parking status. Now this is what we set as a data type because we have already created it. It should be accessible. So we'll just say alter table parking detail and add a column called status. We'll proceed to remove it, but this was just for us to understand how to manage enums. So we'll define it to the data type of parking status, what we've just created, and then set it as not null. So let's try and run this and see. So I'll click on run selected and it's successful. So I'll head over to my table editor, head over to my parking schema on my parking detail table. I should be able to see it, as you can see. So we have a column called status of data type parking status. So this is it's set as a category of other data types or custom data types that you have created for yourself. So when you click on this, this will hold the three statuses, and all you have to do is save based on either it's ongoing, completed, or cancelled. So you only use enums whenever you want to just set predefined constants within. So that means whatever you're going to save in that specific column is either or whatever that you have set as constants in this specific custom data type that we have created. So only this constants will be set. So if somebody decides to add another type of constant, for example, pending, from the front end, it should not be able to save because already it knows that this custom data type only holds three types of constants. I hope it makes sense. Next, let's create the parking slot table, which was what was pending in there. We needed a column that holds a relationship between parking slot. But before that, let's proceed to create the parking flow. Let's just create the parking flow first. So we'll create a new table, name it parking flow. This will just contain a list of names of parking air floors. Simply as that. Then we retain the settings together with the two columns and just add one column called name of data type text, not nullable, and click on save. Done. Let's proceed to parking lot. So I'll create a new table, call it parking lot, and we'll give it a description. So it will contain information contain a list of parking lots for specific parking areas Great. So we retain the settings as they are and then proceed to add a new column. So we'll have two columns. We'll have the parking area ID, which makes sense. And then we'll just set it as int 8 and set it as not nullable. Then we'll add another column for parking floor ID, int 8. And then let's create a relationship. So we want to create a relationship, two relations. So the parking area ID will create a relation between the parking lot table and the parking area table. And the parking floor ID will create a relation between the parking lot table with the parking floor table. So here's the kicker. So parking lot, we have a parking area. A parking area has multiple parking lots, and each parking lot has a number of parking floors. Okay, so that's the idea. So we need the parking area where this parking lot is, and then because we're going to have a list of parking lots, we'll need to be able to have a record of which parking floors that this parking lot has. We'll get to see it once we have some data entry into the tables, and I'll be able to share the CSV file for you to just add it to for your test in this tutorial. So now let's create the relationships. So we'll reference to the parking area, which is in the parking schema. So we just need the parking area, and we want to create a relation between the parking area ID and the primary key of the parking area table. Click on save, and we'll add another one. The parking floor is also in the parking schema. So with reference to the parking floor, so we're just creating a relation between the parking floor ID and the primary key column of the parking floor table. Click on save, and then we can proceed to click on save, and we'll be creating a new table called parking lot. So it failed to fetch. Let's see what the problem will be. Not sure what the problem is. Let me try and remove this too fast and click on save. We see there shouldn't be a problem. Something to do with the relation. So let me just try again. Edit the table and add. So we have in the parking schema, we have the parking area, and we're connecting the parking area ID with the ID of the primary key column of the parking area table. Let's save that and see. So that has gone through. Let's edit the table again and add the second relation, which is in the parking schema. With reference to the parking floor, we need the parking floor ID and create a relation with the primary key column of the parking floor table. Click on save. Let's try and save that. Great. So I'm not sure what happened, but we just returned the relations and we are good to go. Now let's proceed to create the last table, I believe, because we have designed, I think, all of them. We're just remaining with the parking slot. And remember that the parking slot, we also need to create a relation with it and the relation between the parking detail table and the parking slot. So let's just create that table and finish up. So we'll have a table called parking slot, and this will contain a list of names of parking slots in a specific parking lot. Great. So we retain the settings and then we add a new column. So our first column will be name. So we may have, as I showed, we discussed an example when we were discussing on terminologies. A parking slot will be like G1, for example, that means ground floor number maybe 1. So it refers to the names themselves, G1 or A2, depending on what the names that the parking area is giving the specific slot. So we'll just give it as, set it as name and give it a type of text. And just make sure it's not nullable. Then we'll add another column called availability, and this will be of type bool. So is it available or not? That's all it means. And then just make sure it's not nullable. And lastly, we'll have the parking lot ID, which will be of type int. And this is the column that will create a relation between the parking slot table and the parking lot, because a parking slot is inside a parking lot. So we'll just set it as not nullable. And now that we have that, let's just create the relation right away. So we are in the parking schema, and we just specify reference to the parking lot. And we just need to create a relation between the parking lot ID with the primary key column of the parking lot table, and click on save, and then we proceed to click on save. And with that, we have created all our tables. So in the parking schema, we have 1, 2, 3, 4, 5. We have 5 tables. And in our public schema, we should have 3, 1, 2, 3, which seems to be the case here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Great. So we have finished creating or designing our tables. Now let's proceed to the next step.